we're doing, right? Java programming, and in basically in computer science, right? Java was actually a very popular language a few years ago. Right now, I would dare say it's on a declining trend. I think languages like Python and JavaScript have slowly started replacing Java at a large scale level. But however, right, Java is important because it was one of like the most popular languages a few years back, and it teaches you like very important concepts such as it's an object-oriented programming language. So it teaches you how to build objects and how you can manipulate them to create like large programs that are usable. So where Java was particularly used was you have machines right at home. I think washing machines and stuff like that. So it was used to integrate with the machines to make them smart. Like you set a timer for it, how much you want to wash, and how many RPMs you want per minute, and things like that. Even I think mixers and stuff like that. So do you guys know of anything like smart machines that you guys use at home? I mean, not smart. Smart is something again because now smart is defined by artificial intelligence. So that's going one step ahead. But there are machines, right, that you can input controls in and make them work. So do you guys know any machines like that at home?
Fans.
Yeah, fans. Oh, okay, see, fans is a bit electronic now because you have these regulators, right? It's it has to do with electronics the most, but that's actually a very good thing, right? You can even control fan speeds, correct? The RPM there. Anything else, guys?
So like dish or dishwasher.
Perfect. Dishwasher is a brilliant example. Dishwashers, ovens, and things like that, right? So now you guys understand, like, why programming is so much important. Like, we just see a dishwasher or ovens and see, like, yeah, it's not big of a deal. It's just a machine that we bought and then we try to use these things. But because of programming, right, that was made possible. So that's why it's essential that all of you learn programming. And I think the future is going to be defined by how well we program and stuff and build applications out of it. So let's get started with the core material. So here's what we're going to be learning, right? Control statements, conditional statements, and looping statements. So, right, this is the assigned topic for me, and this is what we'll be studying, right? Does any of you know what a control statement is? Right? Audible, guys? Hello?
Sir, you are audible.
Oh yeah. I mean, see, just give it a guess, guys. Like I'll tell you, like if I was going to guess for something, right, I would be wrong. Like, how old are you guys? 16, 15? Something like that.
I am
I'm
16 this year.
Yeah. When I was 16, I was like 15 to 20 times stupider than you guys, right? So like even if you tell me something like really stupid, and that's going to be much smarter than what I was at that age. I mean, even probably right now, you guys are much smarter than me. But that's the thing. So just give it a guess. Any random guess. Okay. So, okay, let me just go ahead and see. Okay. Now, what do you guys think a flow of a process is? Can you define me like, what do you mean by process flow?
step by step
Perfect. Step by step actions to
procedure.
yeah, correct. Beautiful. That's a beautiful definition. A step by step process to achieve a certain result. And that's actually a very precise definition as well. Because even in computer science, right, when we define things like algorithms, we say they're a step by step procedure to get a desired output from a certain input, right? So, and anything else, anybody else wants to give a guess what a flow is?
So like getting the output for some particular code in like a step-by-step process.
Yeah, correct. That's a very well-rounded definition of the whole process, right? So let's just look at the definition once. The flow of a program specifies in what order the code will be in the program will be executed. By default, the flow is sequential. Okay, so can you guys give me? Do you guys know what sequential is or a sequence?
Like going in order.
Perfect. Going from the start to finish, right? Can you guys give me an example of a sequential process that happens in everyday lives?
So like sequential in everyday life.
Wake up,
Wake up.
brush,
Right?
brush, bath, and then
Perfect. Yeah. See, that's again like see here, right? We have this getting ready for school example. So you wake up, go to bathroom, wash hands, eat breakfast. See, this process has to be executed in a sequential way to get the desired output. See, you can't go to bathroom before you wake up. See, that doesn't make sense, right? How can you be in the bathroom before even waking up, unless like
Yeah.
somebody's lifting you and putting you in the bathroom, but it's not possible, right? So usually, like many of the processes that we see in real world are sequential, and they make a lot of sense in getting a desired outcome. But sometimes, right, we're not happy with only a sequential process. Sometimes we need a sort of conditions, right? Now, let's say, what are you guys' names? I didn't read them properly. What are you guys' names?
My name's Likit.
Likit and
Nishant.
Likit, Nishant and
Uh, Akshay.
okay, Likit, Nishant and Akshay, right? Right. So let's say Nishant wants to go to school, right? And normally every day is following a sequential process of waking up, getting ready, brushing his teeth, putting on his clothes, and going to school. But let us say that on one day it's some holiday for some school for some reason. So will he follow the same sequential process that day? No, right? Like because it doesn't make
No,
sense.
he won't.
Yeah, perfect. It doesn't make sense. Like why would he get up, get ready, put on his clothes? So there we can define a condition. We can say if school is not there, Nishant go sleep for 3 more hours. If school is there, then get ready. So again, right, we have turned a sequential process into a controlled process, right? So we are sort of having a decision making process there to turn a sequential process into a control process. So now let us look at what control statements are. So, just by looking at the screen, right? Can you guys give me some examples of control process right now, right? I told you like how sequential processes are not always good. So, can you give me another example where a controlled process in your life will be better? Like, yeah.
So, like, can we say like the timings in which we eat food?
Right. Yeah. Perfect. That's a control statement. If time is 3 p.m., then
Like,
probably.
if it is like vacation, like you'll get up a bit more late, so you'll eat your breakfast a bit more late, and then
Perfect,
like that will
perfect. See,
change.
that is a very good example because now we are talking about the whole process itself is different, like on vacations and during school time. And you guys go to play outside, right? Football or cricket or something like that.
Yes.
Also, on some days, because I had this experience a lot, some days people don't turn up as much. Like instead of 10 people, there'll be like 3 or 4. That day, you guys just have to talk for a while and go home. So we can define a condition there. If the number of people haven't come, then just chat and go home, right? So those are the conditions. So now let's see what control statements are. Control statements control the flow of the program, deciding what statements will be executed, when they will be executed, in what order, and how many times. Right? So this is what control statements can bring to your life. Now again, control statements, right? In programming in general, we have two varieties of control statements. One are called conditional statements, and one are called unconditional statements. Right? Right now, let's not get into the details of this. Let us go ahead with explaining what a few conditional statements are, and probably you'll build an understanding of how they use and how you can go about them, right? So let's look at the first process, conditional statements. Okay, now I'll just give you an example of conditional statements, right? The first in this first image, right here, you can see a kid showing his report card to his dad. So let's say this dad made a deal with this kid. He's like, if you get above 90%, I will buy you a car. Not car, some carom board or something, right? Now that's a condition, right? So we have an if statement there, right? If you get above 90, I will buy you a car. So if, and there's a condition that follows it, and when that condition is true, a block of like promises will be executed. Like if it's true, he'll buy him a car. The second thing, if you are above this certain height limit, you can ride in the amusement park, right? That's again a condition. If, and there will be a truth value to the condition, and then if that executes to true, then you can go ride the this thing. And here, right? Can you guys tell me like what is common amongst all of these people? Like, can you tell me these are guys standing in this water's queue? So, what should be the condition for all of them? There is a certain condition we defined, right, for all voters in India. So, what is the condition?
They
So
should
the,
be above 18.
Perfect. If a person is above 18 years of age, then he is like applicable to get a voter's ID, right? So again, there's a conditional statement. So now, let us look at a formal definition. Condition statements allow you to execute a set of statements depending on well-defined conditions. Right? Now I'll tell you why well-defined conditions I have written here and why that's important. Now let's say like Likit, right? Likit was your name, right? So Likit, I asked Likit,
Yes, sir.
do you want lunch? And he's not telling me yes or no. He's just like maybe. So when if he says an answer like maybe, it doesn't give me the right let's say course of action. If he's hungry, I'll probably tell him, bro, then go have a break and eat and come. If he tells no, then I'll be like, okay, let's continue the class. But if he's telling me maybe, then I don't know what to do, right? So that's important, right? Condition statements always have to have a well-defined goal. Like if when you're saying if you get above 90%, that's yes or no. Like somebody like once they get the report card, it can't be both higher than 90% and lower than 90%. So it's a well-defined condition, right? So that's how
Yes.
condition statements work. Now, okay, guys, if any doubts you have, right, when I'm explaining, and if you feel that I'm like going too fast or going too slow, anything, just stop me and tell me, right? And don't call me sir, please just call me bro. Yeah. Right, guys?
No doubts. Yes.
Can you just be a bit louder?
Yeah. Can you hear me? It's my
Yeah, I can hear you.
Yeah.
It's okay. So I'm just going to take that as you guys are okay with whatever is going on so far, and I'll continue, right? So
Yeah.
if statement. An if statement is used to execute a block of code if the given condition evaluates to true, right? So this is the syntax for it. If, like I told you, right? Now let me like actually track it back to the previous example. So if Nishant gets above 90%, block of statement will be Pankaj sir will be very happy, right? So if the condition that Nishant gets above 90%, that evaluates to true, then Pankaj sir will be very happy. Then if this doesn't evaluate to true, this statement will not be true, right? Pankaj sir won't be happy if you do not get 90%, right? I mean,
Yes.
marks aren't that important, guys. That was just an example. Uh, so okay, so let's just look at an example. Okay, now let's see. You guys have a little bit idea about the scanner class?
Yes, sir.
Yeah.
Okay. Hmm. Okay, even I forgot the. This was the syntax. Interesting data. Oh, sorry.
Inside the bracket, I think it's system.in.
Yeah. This is see, these sort of things can happen no matter like how much practice you have. You always come out and do like so. Again, mistakes will happen, but then you just have to correct them, right? Okay. So let's say let's give an output system.println. Hello, enter the number. Okay. Then we have int a is equal to integer dot pass int send dot next line system dot out dot println enter the number b int b is equal to integer dot pass int send dot next line. Okay, this may be too hectic. Send dot next line. I'll just replace that, right? Because these things you can do, both will work, but it makes more sense writing it as sn.nextInt, right? It's just better practice, right? And okay, whenever you initialize a scanner class, right? I don't think it's very necessary that you guys do this, but if you write the statement, right, it's something like sn.close, right? So you're actually telling the computer to give you a certain resources, and you're telling them to like I've done using those resources, so I don't need them anymore. So you usually it's just good practice when you specify sn.close, right? Okay. So now let me just explain what's been going on in this program. I'm telling the user to enter two numbers a and b. Now, if a is greater than b, system.out.println a plus yeah. So what does this code do? It takes in two. It prompts the user to enter two numbers a and b. We read those two inputs in integer a and b, these two values, and then we compare them using an if condition. Now see here, right? I want you guys to notice one thing. I write if a is greater than b. So whenever we use symbols like greater than, less than equal to, or equal to, what value will they return? What do you guys think?
Like A or B.
If A, okay, like let's say if Nishant is 6 foot tall, so what are the possible answers for that question? If is Nishant 6 foot tall, what is that? What are the possible answers?
Like yes or no.
Yes or no.
Perfect, perfect. That is what I wanted, right? So these are called binary answers, right? So it either is yes or it's no. It can't be like he's both, right? It's not possible. So these in programming language, right? We have something called Booleans. You guys know something about Booleans?
Yeah, like true or false
Perfect,
Yes.
values.
perfect. So, right, that is like the right understanding for the question. So, if A is greater than B, it always evaluates to a true or false statement, right? So, from here, what I want you guys to take away is that whenever we use an if statement, the condition should finally evaluate to a true or false statement. Okay?
Yeah.
Yes, sir.
Yeah,
Yes.
because right, we have another set of statements called switch. Switch acts on integers and characters. If always acts on booleans, right? So that is the simple takeaway from this. So now we have if, then we have an expression that evaluates to a. I'll just write it here. So expression, okay, condition. Uh, Sorry, I'm very bad with spellings. Evaluates to a boolean value, right? That is very important. If and if this statement is true, it will execute this statement. If it is false, let's see what happens if it's false, right? So if, let's write this, enter the number A. For number A, I'm giving the value 10. For number B, I'm giving the value 3, right? So it's saying, oh, 10 is greater than 3, perfect, right? We have executed our code and we are very happy with ourselves. We pat ourselves on the back. But now let me do something else, right? Enter the number A, enter the number B, right? Now see, it's not telling me anything. I've entered number A as 3 and entered number B as 10. But then that's it. The program is terminated without me knowing. Like I don't know. I don't even know what's happened. I know if A is greater than B or if B is greater than A. So I have no clue. So now let us look at the second set of statements, right? And this we have the else statement. Now, an else statement is used to execute a block of code when the if condition evaluates to false. So, when did the if condition execute? When this condition was true. But the else block will always execute when the if statement is false, right? And it is important to know that it can only be used in conjugation with an if statement. So, else statements cannot be used alone, right? You can't just be like let's say I want to tell some guy that I'm really angry, bro, don't make me angry or else I'll hit you, right? There's a condition to it, and there is a, if you don't accept, like if you don't like let's say accept my conditions, then I will hit you, right? I just want to say I'm a pacifist. I don't encourage anybody hitting anybody. That's a very bad thing to do, but let's say that was an example, right? So it always comes with a condition. You can't simply go and say else I hit you, else I hit you to somebody. They'll think this guy's not even making sense, right? So if statement is always used in else statement is always used in conjugation with an if statement, right? Now let us see. Now let us see how we can implement else statement in our this code to make it more sensible, right? So we have one condition: if A is greater than B, system.out.println A is greater than B. Now what is the other condition that you guys can think of? Right? If A is greater than B is false, what is like the other like obvious condition?
Else B is greater than A.
Perfect, perfect. Now we had if, right? Now else. Right, else. Now see, one more thing that I want you guys to note right here is whenever you write else, right, when there is only for this else statement, there is no condition. Now why should there not be a condition for else statement?
Because it's default.
So like
Perfect.
else will only execute if the if is false. So there's
Perfect,
no need to
perfect.
put
That
it.
is the right answer because see, we have already checked the condition. If else executes based on the like false value of the if condition, so we don't need a condition there. So it makes no sense, right? So when if evaluates to false, then we have our else statement. So system dot out dot println b plus is greater than plus a, right? So now let us run this program now. So enter number A is 3. enter number B is 10, right? So 10 is greater than 3. Okay, perfect. Now again we are told, oh my god, we are so brilliant. We have executed this program, we've understood everything. But now let's see something else, right? So A is 10, B is 10. Okay, so what is this? You guys are asking me, bro, what is this? It doesn't make sense. You're saying 10 is greater than 10. How is this possible? Right? Are you stupid? Right? Then now I missed something else. Right? There is a third condition. A is greater than B, B is greater than A. And what is the third condition?
If A is equal to B.
Perfect. That is the third condition, right? Now let us look at the third part of statements. Now this we call it as if else if ladder. Now it is used to execute one block of code when there are many possible conditions. See, as long as we have two conditions, we are fine. We can use if else and get away with it. But what if there are three? What if there are four, five, six conditions? Like let's say I'm in charge of assigning a school report card marks. Saying if student gets above 90 is A grade, above 80 B grade, above 70 C grade, and so on. Those are multiple conditions. Those are not just two conditions, and I can't use if or else. Now, when can I use if or else in that marks process? If student is getting above 40, he is passed. If student is getting below 40, he is failed, right? Those are two conditions. But when there are multiple conditions, we can't use only if else. We have to use an if else if ladder, right? So it is used to execute one block of code and there are many possible conditions. It is also referred to as a multi-path decision statement. So why is it a multi-path decision statement? Because see, there are many conditions. There are like, if you are willing enough, you can write thousands of conditions, right, for if else if ladder. So that is why, depending on the condition that evaluation do, it can execute one of 100 or so statements or many, like more than two, right? So that is why it's called an if else if ladder. Any doubts, guys?
No.
Yeah, perfect. So let me incorporate the third condition. So we have our first condition right here, second condition right here. So now third condition. Okay, right, see, here we have if and here we have else statement. Now whenever we want to add another statement, you always have to use else if, right? Else if A
Yes.
B system two numbers. Okay, one more thing I want you to note here is, see, because an if statement appears here, right? Else if just uses as a trick, right? Whenever you see an if keyword, there always has to be a condition. Okay.
Okay. Yes.
Whenever there is if, whenever there is an if, there's a condition. So what are the key takeaways? Three key takeaways. So condition must evaluate to a Boolean value. When there is no, when there is only else statement, there is no condition. And whenever there is an if, there is a condition. Right? Those are the three key takeaways that you guys have to have from this. So now let us execute the program for one final time. Now enter the number is 13, enter the number B 30. So the two numbers are equal. So right now using if, else and else if, we have covered all the scenarios, right? If one number is less than the other, if one number is greater than the other, finally they both are equal, right? So those three cases have been covered. So any doubts so far in if else statements, guys?
So like I have a doubt.
Perfect, yeah.
Here until now I've been using scanner as like the default statement as scanner SC is equal to new scanner, but you're using it as SN, so
okay, see,
is both correct?
In variable names, right? Anything can I can even use scanner Nishant, right? So it will still.
Oh, so it will be correct.
Yeah, because see, these, right? These are basically like variable names, right? Nishant is an object of the class scanner, and it can have any name, bro. It's always right? And even here, right? All these data type names, you can give anything you want, really. But as like a rule of thumb, right? When you're working, let's say in a company or something, not only you are going to be reading a code, like you're going to be working with 50, 60 other guys. So if you're using something like your pet's name, or you're using like whatever names you want, or your favorite actor's names, they're not going to understand it, right? So it's just a rule of thumb, but it was a very good question, right? Because even when I started out, I had similar doubts like this. But I hope you understood. You can use anything, right?
So also like one more, whenever I do programs in class, like some of my friends in public static void main, they sometimes don't put string args, or like sometimes they put it. Like I don't get it, when do you put it and
No,
when do
no,
you
no.
not put?
See, whenever you write, right, string args is very important because apart, I don't think the program executes, right? So, because see, this is just like something, right? The compiler does internally. It needs certain arguments to be passed to it before it can execute. Right now, that is too detailed right now to understand what those arguments are and how they're passed, right? But that much you can understand that always have to put, right? Just
So like in
blindly,
every program,
yeah,
compulsory, like we have to put string args.
yeah, whenever you write, like, see, this thing, public static void main string args. Like, I'm
Okay.
just telling, close your eyes, trust me, and put it. That's all. Right?
Okay.
So, always do that.
Yes.
And any other doubts, guys?
And also that sn dot close, what is that used for?
Okay, so see, sn.close. See, this one, I think when you guys are writing your programs, you guys generally don't specify it because, again, because when the program is terminating, it's usually considered okay, fine now. When the program by default, right, when it ends, like all the resources will be closed. But sometimes, right, it's just good practice to specify that I have used the scanner, I don't want it anymore, so I'm just closing it. It's like this, bro. It's like you borrowed your pen from your friend, right? To like, let's say, write the title of some notes or something. Once you've written the title, you have to return it back, right, to him.
Yeah.
Or else, like, it might be the period is over, then by default you'll return it. So it's just good practice to write sn.close. You're telling the compiler, see, I've taken these resources, I've used them, I don't want them anymore, so I close the resource, right? It's just good practice. But even
Yeah.
if you don't write it, it's fine. It's completely fine.
Okay.
Yeah. Any other doubts, guys?
No.
No doubt, sir.
Nothing, sir.
Okay. So you guys are just using scanner class, right? You guys are also using buffered string reader. I mean buffered reader, sorry.
It's only scanner for now.
Okay, fine, perfect. So let's go to the next set of examples. Okay, now we have finished if else if ladder, right? And I think we have developed a small understanding of what if else if ladder is, right? So now we come to the next part, iterative statements. Okay, now I'll just explain a few iterative statements right here, right? Like a woodcutter, right? He's going to cut wood with his axe, and he is going to chop the wood as long as the tree is not cut, right? So that is an example of an iterative process. We have a condition there: as long as the wood is not cut, I mean tree is not cut, chip on the wood, right? Keep hitting into the gas. Now that is an iterative process. The end goal is well defined, that like he has to stop when the tree is cut, right? That is the end goal. Now we have our second example here. Let's say you're going on a walk. Let's say you walk to school. Nishant, Akshay, right? Akshay was the other person.
Yes, sir.
Akshay, yeah. So Akshay, let's say you're walking to the school, and what is your end goal there when you're walking to the school?
Like my end goal, so I have to just keep walking until I reach the school.
Perfect, perfect, perfect. So the iterative step there is you take one step, you take another step, you take the third step and fourth step. The end goal is when you reach school, you stop. So the end goal is very defined, and the iteration is also very well defined. So you keep taking steps. Now let me define other iterative process. Let's say your teacher is giving you some imposition to write on the board, right? You have to write. Let's say, like, I will not make noise in class 50 times. So what is the end goal there?
Like to write 50 times on the board, like I will not make noise.
Yeah, the end goal there is once you have written the 50th time that I will not make noise, the process is completed. And what is the iterative step? Writing I will not make a noise. I will not make noise in class. That is the iterative step. So we have both our iterative step and the end goal well defined. So those two things have to be well defined, right? What statements you want to be executed and what is the end goal of these statements. And see, every time I write, I will not make noise, right? So the number of iterations is increasing. So I write it once, I write it twice, I write it thrice. So you see, right, with each iteration or with each time I perform a certain step, I'm getting closer to my end goal, right? So I'm not getting farther from it. Like, let's say there is some, let's say,
Yes.
like, there's some really crazy person. He's telling me, you have to write imposition 50 times. But every time you write once, I will add one more time to the imposition. That is a never-ending process. Right? I will never reach.
Yeah.
Every time I write once, he's going to increase it. So okay, so this has to be very clear. I mean, about our iterative statements when we write them, there has to be a well-defined end goal. There has to be what steps we are going to execute in each iteration, and every time we iterate, we are supposed to get closer to the end goal, right? Now, just for fun, I'll just show you a process that will never end, right? System.out.println. Yeah. So see, this program keeps on going, keeps on going, keeps on going. It never ends until I terminate it like manually. Now, why is that? What is missing in this statement?
Like a number of times you have to print hello, like you have to specify the number of times.
It's not a true or false statement. There's no false.
Perfect, perfect. That's actually a very nice way to put it. There is no false statement. See, that means there is no time or while statement will evaluate to false. So while statement will stop executing when it evaluates to false. But if there is no way that the while statement evaluates to false, then it will keep executing, right? So end goal is not well defined. But what is well defined here? The process is well defined.
To print hello.
Yeah, perfect. So now we see, right, the problems why all these components have to be involved. Now let us see. Let me give you another process of when this thing will again become useless. Int I is equal to 10 I plus plus, right? Sorry, int I is equal to 0, I less than 10, right? So now let me say I'm just executing this. I have yeah. Okay, now what happened? What happened, Vaishnav? Why is my code not executing? Is there something wrong with my compiler, or is there something wrong with my IDE? What do you guys think the problem is? What's wrong? See, this code executes logically, right?
The process is not well defined.
Perfect. See, I have no process. Okay, let's see. There is a process, and it is well defined. It is not. I have no useful process, right? I have no useful process. But everything is there. See, here we have a well-defined end goal, while I is well-defined end goal, and we have with every step we are getting closer to the end goal as well. Right? So we have two things. We have well-defined end goal as well as we are getting closer to the end goal. But what is missing there? I have no useful process to follow. Right? So this is why, guys, whenever you are writing programming, or just as a rule of thumb, I would say, when you write a program, just see if all three constants are there. Just see if the while statement, the condition that is defined there is well defined or being online. Yeah. So you guys can hear me now? Perfect.
Yes.
Yes, sir.
Perfect. Yeah. I'm sharing my screen also. My screen is right.
Yes.
Perfect. Perfect. Beautiful, guys. So let's go with that. Why this? See, we here, right? We are getting closer to the end goal when I say I plus plus. We have a well-defined end goal as well, but I have no useful process to perform because I've not defined it, right? So as a rule of thumb, guys, I would suggest whenever you're writing a program, just see if all these three things are included. We have a well-defined end goal. That means the condition should evaluate to false at some certain stage. Then with every iteration, we should get closer to our end goal. So see, I starts at 0 and goes to 10, and in each step it is increasing by 1. So now let me show you when we are not getting closer to an end goal. Print system dot out dot print hello. Yeah. You guys can hear me, right?
Yes, sir.
Yeah. So again, see here again we have an infinity loop case, right? Again, I've done something wrong. What have I done wrong here?
We are not going towards the end.
So like you put I minus minus, so it's
Perfect,
just staying in
Yeah.
zero.
We are not getting closer to the end goal, right? So those are the three key places that you can have an error in. So I hope that scenario was very clear for you guys. So now let us look at what our PPT says, right? Okay, you guys understood the syntax, right? So just to again go over the syntax. So while and condition, right? So whenever while comes, there has to be a condition. And one more thing, let's look at the formal definition. It is an entry control loop that is used to execute a block of code until the condition specified evaluates to false. So I think this part we understood, until the condition specified evaluates to false. But what does this mean? It is an entry control loop. What have I said? Have I said something wrong? So why do you think it's called an entry control loop?
I'm not sure.
Yeah. Anybody else? Anybody else just wants to give a guess? Entry. What does entry mean? Okay. What does entry mean?
The user gives the input or something like that.
Not quite, but that's a good guess. There is some concept of entering some data there, but not quite. What do you guys mean entry in like a general life scenario? Let's say an entry into a room.
So like does it like check the condition at the time of the entered thing?
Perfect. Who was this? And that is
Beautiful.
That I can't define it in a better way than that. Entry control loop means when the control of the program tries to enter into the block of code, that time the condition is checked. So if the condition is checked before the program executes the block of code at the start, it is called a entry control loop, right? So that is the perfect definition. It checks the condition during the time of entering the block of code, right? So, okay, now let's just look at the definition again. It is an entry control loop that is used to execute a block of code until the condition specified evaluates to false. Now, let us look at something else. Do you guys know anything apart from while statement? Do you guys know anything else? Like
For
okay. With while statement, there is another statement that
Do
while. Perfect. So now we go to the next part. It's called the do while statement. Okay, now do while statement, it is an exit control loop. The block of code is executed at least once and the condition is checked for at the end of an iteration. Right. Now, what is the difference here when I say it is an exit control loop?
so an entry control, if the condition is false, it won't execute. But since this is an exit control loop, it'll at least execute once because it checks the condition in the end of the loop.
Perfect. That is perfectly the right definition for it. I mean, it encapsulates all points of a do while statement because see, the one point you told it should execute at least once. So program is just telling, okay, let me enter into this nice little block of code, let me execute it, and it is only checked at the time of exit. So no matter what condition, even if it is false, it will at least execute it once. So let me just show you. You guys can see the code, right? So do
Yes.
while. Okay, guys. What have I done? Have I done something stupid? System dot unreachable. Okay, yeah. Okay, so actually, right, this is because our IDs are so smart nowadays. It's basically telling me I've written while false, so it's am I stupid? Am I saying how can I execute this statement because it's already false, right? So I mean, it's actually throwing an error, but if I could show you guys, this will not execute anything, right? Because whenever, okay, this might be while one not equal to. Why does it check the condition? Okay, for now, just take my word for it, guys. When I say while false, right, it won't execute the code within. Maybe
Yes.
try figuring something out. This Boolean while false. Okay, yeah. Somehow, right, when you put it in a variable the compiler or something is not smart enough to recognize that I'm putting the value false, right? So that's actually good. Now, what do you think this? I'll just comment this part out for now. What do you think this code will execute? What do you think the output of this code will be?
So I don't think it will be nothing will be there, I think.
Perfect, perfect. Now let me just try to run it and see. See, now no output. That is because while is an entry control loop. So we are trying to evaluate the value val, and it comes in and says, oh shit, this is false. I don't want to execute this code. And the compiler is like, yeah, good stuff, guys. I'm off. Right? Or whatever is executing the statements. Now I'll just comment this part out. Yeah, I'll just comment this part out. And I'll put it here. What do you think this code will execute?
So like the do statement.
Yeah, how many times will it execute?
It'll execute once.
Perfect, perfect. That is exactly what will happen. So see, we have do while. So what's happened here? The execution of the code comes here. It comes to the do statement. It just says, okay, let me do this, execute this once. And once it prints out do while, it comes to this while condition. This while evaluates to false. So at the time of exit, it understands that I should not execute this code anymore, and it goes out, right? So I mean, it jumps out of this do while loop. So that is the difference between a do while loop and a while loop, right? So those are the basic while and do while loop, guys. Any doubts so far?
So is there like order in which should we put? Can we put like do first and then while afterwards, or should we?
It's always do and then while, okay?
What does val do?
Val. Okay, so why I added val here, right? So now you see, if I do something like this, what happens is, see the whatever. Actually, I think this is the ID itself, because I put the value of false here, right? It's saying that no matter what code I put in here, can you guys see what's written in the tag here? Unreachable code, it says.
Yeah.
Yes.
Wait, somebody's trying to come. Just let them know. Okay, yeah. So basically, it's saying unreachable code, right? So that means like the ID is trying to tell me, bro, it's going to be unreachable. Why are you trying to put me in? So that's why I just added val here, just to show you guys what happens when I add the value false. See, right now the ID is not able to understand that this statement is going to evaluate false, so it will execute. So that was the difference, right? And any other doubt, guys?
Oh, no. Okay.
So the condition we should give it after while, like inside the bracket there will be condition.
Yeah, perfect. Whenever you write while, right, there has to be a condition specified with it. And it's the same thing, right? We at a previous example we looked at if. Whenever that if keyword is there, you always have to specify the condition, even if it is an if or else. These three things you have to remember, right? When there is a while, there will be a condition, and always remember it is just like the if statement. This has to evaluate a Boolean value, right? So here you see a Boolean condition here. I mean a Boolean data type here, right? And this will evaluate based on a Boolean value, right? So these things are the key things that you have to remember while writing your code. All right. And now that we have covered all these, like any doubt, guys, up to this?
No, sir.
Yeah, perfect.
No, sir.
So now let us. Okay, now we have covered all these statements, and now let's see if we can make something useful from all of these statements, right? So we covered if statements and else if and while statements, right? So can we do something useful? Now let's put all this learning together and try to code a number guessing game, right? So let's just see how that would go. Right. So let's see. Let me just open a new thing. Okay. Void main. See, once again you see, right? Whenever I specify void main, always string args goes in, right?
Yeah. So does it matter like if we put those two brackets after args, or should we put it in between string and args?
This one I'm not sure. I'll just check. I've been using. Shouldn't matter.
You can put it after as well. It will work fine.
Yeah.
And in fact, when you run it from Doge, you don't even have to write string args, because this is mainly when you run it from command prompt, where you need to pass the file name as argument. So just like your HTML files, you can also write Java files in a Java programs in a notepad, save it as .java, and go to those DOS command prompt and run the compiler directly from there. Then this is required. In other cases, it's not really required as such.
Oh, this is actually even a new learning for me, sir. I just had
Okay.
string args every time, so I just got used to it. Yeah.
Yeah, okay.
So, so we have two things, right? Let's just try to build this number guessing game, right? So in games, right? Whenever we're playing any game or something like that, we always have a random element to it. Can you guys imagine that you're going to play cricket and he's going to roll the ball the same way every single time, and you're going to hit it for a six? It's not fun, right? So every time when we build games, we are going to add a random component to it. So let's say num is equal to math.random into 10 plus 1. So this part, you guys, I'll just tell you what this part will do. Basically, this part you guys don't have to focus on for now.
So Nishant, what is math? What does it come under? You have used it, Nishant, right?
No, sir.
You have used Nishant math, right?
When, sir?
Compound interest, how did you calculate?
Let me check my pro. I don't remember how I did it.
Okay, fine. You can tell a little bit about library class, Vaishnav, maybe, okay?
Yeah. So guys, usually, right, when we're writing, so we saw something else here, right? Import java.util.scanner, right? So whenever you're writing a program, right? Let's say like Nishant, you're writing a project for your school, right? And sometimes you have to go to like your real physical library to get some certain book. Let's say you're writing something about a physics project. So you go borrow a book about physics and then read about it and write it. Now, does it make sense that you carry all the books in your library at all times and then go write a project with it? No. So whenever you write a physics project, you will go to the library and take your physics book and just refer to what you need and then use that, right? So something like that. In programming language in general, right? There are certain library functions that are defined in library classes, right? So when we use something like import java.util.scanner, so this scanner class is there somewhere in this actually comes with the Java bin package, and then you can take this scanner class and use it as and when you need it. So there are other classes like buffer reader and things like that. So you take inputs. Now we have something called math, right? What do you think math will do? The math class.
Like mathematical functions like addition, subtraction, multiplication, division.
Perfect. So see, multiplication, addition, subtraction, they can be like internally implemented, right? So these sort of things, the compiler actually automatically executes. Understands, and the execution happens without needing any special functions. But can you think of more like complicated mathematical functions that you use in your daily life? So what do you guys think? Do you guys use exponentiation like squares and cubes?
Yeah, like squares, roots, and
Perfect. Squares, roots. Can you give me an example of where a square function is used? Like a general example.
So like if they ask us 5 square plus 5 square, so it's like 25 plus 25, which is 50.
Perfect. Yeah. So those things are when you're calculating the volumes and the surface areas and things like that, right? So we have your pi r cube, pi r square, and 4 by 3 pi r cube and things like that, right? And even pi, right? So we have lambda pi, the constant. So these things, right? These mathematical constants and functions are located in this math class, and we borrow these functions and constants and use them as and when required. So that is the use of library functions, right? You can't import them everywhere you go. So you can't, have them automatically like executing everywhere you go. So you just import whatever is needed at the time of execution. Then you use those functions and then execute them, right? So that is the use of math class. So any doubts as to why we use library function, guys?
So library function, is it only to find like roots and squares of?
You can see there are library functions for multiple things, right? We were just talking about the scanner class. Now scanner class is used to take in inputs, right? So we are going to input strings and integers and stuff like that. So there the use of that library function is used to take in input. So in math class, we have functions related to mathematics. So I think we even have the calendar class that is used to manipulate dates and stuff like that. So
So
there's a
all these things are like come under library functions. Like scanner is one of the library function in
it's
math.
predefined and it's available. So now you see, like, these are all like, even this, right? When I say these functions, they are all automatically written and given to us, thinking that most of the programmers will use these functions. Now there are even, like, apart from this, there are new functions. Let's say you have to do something like a face recognition system, or you have to do something with sound, like you're making like this DJ set or virtual DJ set. So these functions, right? These classes won't be available in the standard packages. So what you do is you go and download these packages from online. Okay, somebody would have developed these functions and constants and things like that somewhere in classes, and you download them and then you use them. So it's just simply like that, right? You're importing, like, it's like going and buying a book, right? When your school library doesn't have like some book, let's say on advanced mathematics or something like that, so a librarian will go like buy it separately and bring it to your school library. So things like that, right? So as and when you need these functions and from classes, you just go download these classes, or if it's there in library functions, you import them using this statement and then you use them, right? So things like that. Anything else?
No, sir.
Yeah. So let's just get back to this game example, right? So now what I'm telling the computer to do is, I'm just telling the computer to actually generate a number between 1 and 10. So it'll go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is what that code does. For right now, you guys can just skip over how this code works, and let's look at how we are going to implement it using the if and else statements, right? So now boolean num found is equal to false while num found scanner. I'm just using scanner, right? You guys have scanner. Okay, again, see, whenever I use scanner, you should always remember to import it, right, from java.using.scanner, right? So this thing,
Yes.
yeah, whenever you're using scanner in your program, you have to import it, right? So okay, so until now, what have I done, right? So I'll just explain the basic structure. So I'm just telling the computer to generate a number between 1 and 10. So while so then I'm just defining a boolean value, number found, that is equal to false by default, right? And then as long as the number is not found, you execute the following set of statements. So system.out.println, enter your guess, and I'm just telling guess is equal to sn.next thing, right? I mean, whatever integer the user enters. Right. So any doubts regarding as to what all of this does? So yeah,
No doubts.
yeah.
So this Boolean like num found, like what does num found mean?
Okay, yeah. So like, let's say like when you're playing cricket, right? So what like, let's say the chasing team, they want to chase like a target of 200, right? So can you define a Boolean condition for that? Like if the second team score is below 200, that means they have to continue playing. But if the chasing team score is above 200, they don't have to continue chasing, right? So they've already chased the target. So it is something like that. So as long as the user does not find the number, you have to keep executing, right? So basically what this program will do, the computer will generate a random number and we'll try guessing that number, and we'll keep indicating whether we are closer to that number or not, right? As long as we don't find it. So that is why we have used boolean num found false. So by default it's not found, I have to find it, right?
Okay. So the while num found, while is not equal to num found.
Oh, yeah, sorry. While not num found, right? Okay, see that again is see, because while always execute. When does a while statement execute?
Okay. So if the so while so if the condition is false, it doesn't execute. But if it is true, it executes.
Yeah, perfect, perfect. See that even still today, right? That trips me up. I no, like whenever I use not and etc. Right, it trips me up. But yeah, that's right. While always executes when the statement is true, right? But we want this program to execute when num found is false. So what I'm just flipping it around, or just to make it simpler, while still playing, still playing. Yeah, so now I've just flipped it around, okay, to make it simpler. So, like again coming back to a cricket example, the second team still continues playing until they chase the target, right? So it's something similar. So we are going to continue playing until we find the number, right? So that's why while still playing, and we start executing a block of code. So what I've done is simple, right? I'm just prompting the user to enter, I guess. Then I'm accepting the enter, right? So now, what are the three? See, while comparing two numbers, right, we talked about three conditions, right? If one number is greater than the other, if one number is less than the other, and both are equal. So the same thing we are going to implement here, all right? So if
Yes.
num,
Yes.
if guess is smaller than num, system dot out dot, sorry, okay, now I'm telling the user has guessed a number that is smaller than the number generated by the computer. So what should the computer tell him to do?
Your guess is too low.
Perfect, perfect. Guess higher. Your guess is too low. Else if. No, okay. When else if, right? Whenever there's an else if statement, I have to add a what should I add?
Condition.
Perfect, perfect. So can you guys define me another condition right here?
If guess is more than the number.
Yeah, guess is more than the number. What should I say then?
Guess
Yes.
lower.
Perfect, guess lower. Now, what is the other condition?
Else.
Else.
Else and what should I say?
System.out.println like congrats or something.
Yeah, congrats. Congrats. Oh shit. Congrats, right? Okay, now the number was okay. Now let's just try executing this program once, okay, and see what's gonna happen. Okay, enter your guess. 4. Guess lower. Okay, I'm gonna guess lower. 2. Congrats, the number was 2. But see what's happened here. It says congrats, the number was 2, but it's saying enter your guess again. Now, can you guys tell me why this is happening?
So is it because like we didn't close the while statement?
Oh, I told you three things, right? To always check whenever using while statement. The first one was there has to be a well-defined. Maybe the thing is open. Oh my God, have I deleted it by mistake? Okay, can you just guys just try recollecting it? What are the three conditions?
Sir, I forgot like I plus plus or something like
Yeah,
that.
what does I plus plus do? Yeah, okay, it's
Like you should have a well-defined goal.
yeah, well-defined
Yeah.
end goal. The second one is there has to be a well-defined process to be performed in each iteration. And third one, it says that we are getting closer to the end goal. Okay, now let us apply this logic back to our game. So is there a well-defined end goal here?
No, sir.
See, in a sense, there is. It's saying still playing, right? Still playing will that means you can manipulate it somehow. There is there is a goal. Let's say there is a goal. Let's not say it's well defined. Let's just say there's a goal. Now, is there a usual process to perform in between?
So now here the goal is to guess the number.
Yeah. So have we done that part? Have we found if the user is guessing lower or higher or has guessed the number? Have we done that?
Yeah.
Yes.
Perfect. So the process is also well defined. Now, what is missing?
It's not a well-defined end goal.
No, but the
Oh no, sorry. We are not going
we
closer
are
to the end goal.
are we getting closer to the end goal, or are we literally telling the computer, bro, the end goal has been reached, you can stop executing? Where are we doing that? Are we doing that?
We are not doing it.
Perfect, perfect. So that is what is missing. So whenever I told, no, whenever you guys write these loops, right, always check for these three things. So what are the three things? Can somebody just like put it to me again?
It should have a well-defined end goal. The process should be like can we say well-defined again? Like the
Perfect,
process
yeah.
should be,
You can use it, right?
and then we have to get closer to the end goal in each iteration.
Yeah, closer to the end goal. Yeah. Okay. Sometimes, right? This is a special case when we're not like. See, we can even get farther or closer to the end goal because it's based on the user input. But once we reach the end goal, there has to be something specifically telling the computer, please stop executing. So how can you guys just guess how can we do this? I'll give you a clue. There is something to be added in the else statement here. So why this? See, while still playing is true. So as long as the still playing is true, the program will keep executing. So what should I add in the else statement to make the program stop executing?
False statement, like.
You're very close, very close. Come on, just give it a bit more thought. So I'm telling, while statement will always execute while this condition is true. This condition is defined by still playing, and you told me that there has to be something to make some false sort of statement to be added. So what can I do? Still playing should become
Finished playing or
Done playing.
done playing,
no,
yeah.
not in a word sense. Still playing is true. I should change it to
No, not equal to still playing.
okay. No, see, while, right, it executes based on the condition specified in it, and how the condition is specified through the variable still playing, right? So can you tell me like see, I'll just give you the basic end goal. So still playing should not be true at the end of the when the goal is reached. So how will I make still playing not true?
Should we add like a do loop then?
No, I'll just tell you it's a very simple assignment statement. I'll say like A is equal to 1 or B is equal to 3, something like that. So I should I should change still playing with something like that. So still playing is equal to what will still playing become? So Boolean, what values do they take? Boolean takes
True and
Oh
false.
wait, still playing becomes false.
perfect. Now see, when I make still playing false, so now let's see what happens to this program. So enter your guess 4. So guess higher. Okay, let me guess higher 6. Guess higher 7. Oh, guess even higher 8, 9, 10. Congrats, the number was 10. And what happens now? Is it executing after that?
No.
Yeah, this is
No,
because
sir.
still playing became false. So when I kept executing and when I entered 10, right? So it just said system.out.println and congrats, the number was 10, and still playing becomes false. So now this execution of the program reaches here. And what was a while? While was called as a what loop?
Entry control.
Entry control.
Entry control loop. So see, so it reached here and then it's coming back here. Can you guys see my cursor?
Yes, sir.
So it
Yes,
starts
sir.
executing like this, goes down, then comes back to the start. Now, what is the value of still playing after the number has been found?
0.
Yeah, after the number has been found, I change the value of still playing to
False.
false. Perfect. So now because still playing is false, so what happens then? When still playing is false, where does the control of the program go?
The loop gets terminated. Like the program gets
Exactly,
terminated.
Exactly. So this loop gets terminated, it won't execute further, and it's done and dusted. So it goes up. There's another way that you can actually stop the termination of a for loop. How would you do that in another way? Do you guys have you
Break.
break? Perfect, perfect. That was the exact answer I was looking for. So let's see this how this works. Two. Okay, so it says congrats, the number was 9 and it breaks the control from the loop. See, whenever you add the break statement, what does it do is it jumps the execution out of the parent loop, right? So the parent loop here is while and it jumps the execution out of that statement. So sometimes you have nested cores and stuff like that. The break statement will jump the execution out of the immediate parent loop, right? So that's the use of break. So you can either do two things. You can change the value of still playing to false, this condition to false, or you can use a break to execute the termination out of that loop. So those are the two things that you can do to stop the execution of a loop.
So here, if we make that boolean still playing as false, like the loop won't execute itself.
Oh yeah, perfect. That's actually a very beautiful thought. What happens doing this, right? Yeah. See, there is no execution. Actually, that was a very good thought process. That when I make still going playing pause at the start, it doesn't execute. So yeah. So that was the content, guys. Today we learned about, just to go over things. We learned about control statements. So what are control statements? They actually control the flow of the program. Then we learned about condition statements. So if else statement and if else if ladder we learned. So what nested if else statements and switch statements are, we'll see in our future class. And looping statements, while loop and do while loop we saw. So for loop we'll do it in a future class, and switch and nested if else, right? So those are the things that we learned. And any doubts regarding what we learned today?
No, sir.
No, sir.
Yeah. Everybody's fine. Anything? Any comments or
No,
anything that
sir.
you want to learn? Right?
I'm not sure, like, if do while loop is there in my portion, so I'll check it and I'll let you know.
Yeah. Perfect. That's you do let me know, right? And anything else, guys? Any comments?
No, sir.
Okay. Yeah.
No, sir.
So thank you guys for joining. It was a really fun session for me. Even I got to learn a lot of things today. So it just shows, like, no matter how much time you do coding, there's still a lot of things left to learn. And I would say, like, you guys are starting like what's it, 1 year before your board exams. That's like sufficient time, ample time to get your basics clear and build better things, right?
Yes,
And
sir.
coding is for everyone.